Hey guys, welcome to video 1, Binomial Expansion. This is the first video in a series of flipped classroom style videos that we're doing for Algebra 2 Functions, the Sequences chapter. And this first video is called Binomial Expansion, and we see here from our notes. Now this is a worksheet that I gave you guys that has these problems already printed out. If you don't, you're going to have to write them down, I call this the skeleton of the notes. This is also posted on eChalk, so if you want to print it out, you can get it there. So anyways, the problem says, write the given binomial expansion as a polynomial in simplest form. Binomial expansion. We've actually been doing that for years in algebra. 2x minus 3 squared. But we weren't calling it binomial expansion. We were calling it FOIL, or distribution. Because we know when something is squared, it doesn't just mean square what's inside. It means multiply it by itself. So this would be 2x minus 3 times 2x minus 3. And if we go through the active FOIL, we multiply the first. 2x times 2x is 4x squared. And then you multiply your outside. 2x times negative 3 is negative 6x. Negative 3 times 2 is also negative 6x. That would be the inside, the I of FOIL, and the L for last in FOIL. Negative 3 times negative 3 is positive 9. Now, the directions specifically say simplest form. Basically, what that means is if we have any like terms like we do here in the middle, we need to combine this to be a trinomial of 4x squared minus 12x plus 9. Now notice that there's three terms here. And we had a binomial raised to the second, and we ended up with 1, 2, 3 terms. You're going to see that pattern come up a lot, that whatever exponent we're raising it to, we tend to end up with one more than that. So we'll see that happen a few times in this unit. So this is nothing new. This is called FOIL. But now we're calling it binomial expansion. But it's not going to just be as easy as squaring things, because what happens when something is raised to the fifth power? 2x minus 3 raised to the fifth. And then you'd have 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. And trying to do all the arcs of that, like we did here with FOIL, would be a bit of a nightmare. So we have a formula that's going to allow us to kind of have a shortcut to that. This is the formula for binomial expansion, and it's very confusing until we actually get to an example, which we will in a moment. A plus b raised to the n is nc0 times a to the n times p to the 0 plus yada, 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 yada. This formula is going to get us the terms of our polynomial. Like this will end up being our first term of the polynomial. This will end up being our second term of the polynomial and our third term of the polynomial, and so on. But let me get to an example and show how this pattern actually works out. And that's what a lot of this topic is just following the pattern. You're also going to notice a lot of similarity between this and the binomial probability that we did in the previous chapter, like when we said what's the probability of getting at least 2 out of 5 multiple choice questions right, something like that. You're going to see a lot of similarity. So this is 2x minus 3 to the third, different than 2x minus 3 to the second. We're not just going to write it 3 times and do all the multiplication. You actually could, but it's very easy to make mistakes that way and can get very tedious, especially when this exponent gets even larger than 3. So the pattern we're going to see here is we're going to work with 3 columns. The first column comes from our exponent. Our exponent is 3. That means we're going to set this up as 3, C0, 3, C1, 3, C2, and 3, C3. So whatever your exponent is, it's that C0, and then you go up until you have the numbers matching C3. That's column number 1. Column number 2 is your A term. It's basically the first term of your binomial, in this case 2x. And so it's going to be 2x, and that's going to be raised to whatever our starting exponent was in the expansion, so to the third. And this, instead of going up, like here we had 0, 1, 2, 3, these went up. The exponents here are going to go down. So instead of starting at 0 and going up to 3, we're going to start at 3 and go down to 0. So 2x to the third is the first one, then 2x squared, then 2x to the first, and 2x to the 0. And so we start here and go down. Then our third column is going to be our second term of the binomial, in this case negative 3. And this one, like our first column, is going to go up. So it's going to start at 0 and go up. And so we see an up, down, up pattern here, that our first column is going 0 and going up. Our second one starting at our exponent and going down. Our third one starting 0 and going up. So there's a lot of pattern. And so -3 to the first, and -3 to the second, and -3 to the third. And that's what this formula is showing here, that you start NC0, NC1, NC2, NC, all the way down to get NCN, where they're the same. This exponent starts at n and then goes one less, one less, one less, all the way down to 0. And our second exponent starts at 0 and goes to 1, then to 2, then 3, and so on until it gets to n. I like the column approach, though, because it's really easy to see this pattern. That's the setup, and that's really the key to all this, that your first column, the NCR column, has nothing to do with what's inside. It has everything to do with your exponent. And so our exponent is a 3, so it's 3C0, 3C1, 3C2, 3C3. And then your first term, 2x, starting at that 3, 2, 1, down to 0. Your second term, remember to make sure that this sign in the middle, that belongs to that term over there. So if there's a plus or a minus here, that's attached to that second term. So it's a -3 and starts at 0 and goes up. So we have an up, down, up pattern. Then we need to evaluate these. So 3C0 is 1. Anything 0 is 1. 2x to the third, you raise 2 to the third and get 8. And you raise x to the third is just x to the third. And -3 to the 0, anything to the 0 is 1. Multiply this across, we end up with 8x cubed. Second row, 3C1 is 3. 2x squared is 4x squared. Right? For this, we raise 2 to the second and x to the second. Or you can think of it as 2x times 2x. And -3 to the first is -3. We have a 3, a 4, and a -3 all multiply. That's 3 times 4 times -3 is -36x squared. Of course, you could use your calculator for that too. 3 times 4 times -3. 3C2 is also 3. And again, now I can do combinations like that in my head because I've been doing this for many years. But you could type that into your calculator, 3C2. 2x to the first is 2x. And -3 squared is +9. Now remember, a negative term like this raised to an even exponent is going to become positive. But if you're raised to an odd exponent like 1 or 3, it's going to stay negative. Again, calculator can be very useful with that. I'm just going to get my calculator out in case I need it. But you should just remember that negatives raised to even are positive and negatives raised to odd are negative. And that's going to be very important to keep that in mind. Now, of course, yes, you can type this into your calculator. You just have to be very careful with parentheses. You have to type in parentheses -3 parentheses cubed, and then you'll make sure you'll get the right sign there. So what do we have here? 3 times 2 times 9. Again, I mean, you can type this into your calculator. 3. What's happening here? I got to switch to this. 3. Sorry. 3 times 2 times 9 gives us 54. And so this is, switch back to my pen. Now, I actually like to put a plus sign here for positive 54x. The reason why I do that is because these are going to end up being the terms in a polynomial. We're going to put them together. And remember, this is +9 because it's a +9. So any term beyond the first one, because the first one, if it's negative, I'm going to put a minus sign. But if it's positive, it doesn't need a plus. Just like this 4 is positive here, but we don't put a plus in front of it. You can if you want to, but any term after this first one, I make sure I put the sign in between. I mean, negative we always keep, but even positives, I'm going to put a plus there. And so last row, 3C3 is 1. 2x to the 0 is 1. Even the 0 is gone because 2 to the 0 is 1. Even x to the 0 is 1. So they're both gone. And -3 to the third. So a negative raised to odd. Negative raised to odd. It stays negative. And -3 to the third is -27. All comes out to be -27. Lastly, I put it all together. So my final answer, here's my first term, here's my second term, here's my third term, and here's my fourth term. And it's not a surprise I have 4 terms because I'm raising something to the third. It always ends up one more than that. And so I just put it together as 8x cubed minus 36x squared plus 54x minus 27. And that is my final answer. Now, we do have one more example I was going to do, but I promise you guys I try to keep the videos around 10 minutes, and so that's what it is. So I'll tell you what, why don't you try this one on your own? Or, you know, I told you your homework was this, so you don't have to, but if you want to, try this one on your own, and I'll give you the answer tomorrow in class. And in class, we're going to do a bunch of these, and we're going to, you know, see if we can make sure we get this process right. But so much of it is really just setting this pattern up and then going through the motions and making sure we're careful with our algebra and our exponents and our positive and negative signs and getting the right answer. But we'll talk about that tomorrow in class.